Namaste children. You observe what is given in the slide and answer the question. Now observe the pictures also in case A and case B and give the answer for the given question. In case A lady is wearing sneakers on Monday. You are sitting on a bench reading newspapers. She starts jogging and accidentally puts her steps on your foot. Case B. Same lady is wearing heels on Tuesday. You are sitting on a bench waiting for a friend. She was walking. In order to take a rest, she moves towards the bench and accidentally steps on your foot. That is the situation given to you. Now, what is the same in both cases? The force applied is same in both the cases. What is the different in both the cases? In case A, force applied on a bigger area, whereas in case B, force applied on a smaller area. Now, once again, what is pressure? Pressure is the force acting per unit area. Its SI unit is Newton per meter square or Pascal. Mathematically, pressure is equals to force by area or thrust by area. What are the depending factors of pressure? Pressure depends upon two factors. One is force. More force, more pressure. That is, pressure is directly proportional to force. And area of contact. More area, less pressure. That is inversely proportional to the area of contact. Now, here is an activity. Force exerted by weight of a person 600 Newton. Find pressure. Position A, area of contact. Force, pressure is equals to force by area or thrust by area. The position is standing, sitting, lying down. Area of contact is given, force is given. So calculate the pressure. Now in this example, a person is poked with a finger. Pressure in form of pain due to force will be less. Whereas in the second case, person is poked with a sharp end of a needle. Pressure in the form of pain will. Now what is the difference between force and pressure? Force is a physical factor which is applied by a pull or push on any object, and it is having a particular direction, so it is a vector quantity and changes the property of inertia of the bodies. Whereas pressure is the intensity of force on the area on which it is in contact, and it is not having a particular direction, so it is a scalar quantity. SI unit of force is Newton, whereas pressure is Newton per meter square. The same force produces less pressure if it acts on a large area, but it can produce more pressure if it acts on a smaller area. Now, everyday applications. School bag, a sharp knife, a tractor having broad tires, then heels and flat shoe, bridges and railway track, wooden concrete slippers are kept. Question time. Collect some 5 more examples from day-to-day applications of pressure. Is buoyancy or buoyant force. When a body is immersed in fluid, an upward force is experienced by the body which is kept in the fluid. What is buoyancy force, or what is buoyancy or buoyant force? When a body is immersed in a fluid, it experiences an upward force or thrust applied by the fluid on the body. This upward force is known as buoyant force or upthrust, which is equal to the weight of the fluid displaced by the body which is immersed in it, and is called the force of buoyancy. What is fluid? Fluid is nothing but which flows. What causes buoyant force? Buoyant force is the upward force or upthrust on an object exerted by the surrounding fluid. When an object pushes water, the water pushes back with as much force as it can. If the water can push back as hard, the object floats. If not, it sinks. Once again, what is fluid? A substance which can flow is known as fluid. The liquids and gases can flow. Hence, liquids and gases are called fluids. Example, water, air, etc. Now, whenever you observe the liquid in a vessel, it exerts equal force on all the sides of the object. Fluids also exerts pressure, which is exerting pressure on the container in which they are enclosed equally in all directions. The pressure applied on any part of the fluid enclosed in a container is equally transmitted in all directions, undiminished, to other parts of the fluid and the walls of the container. This is known as Pascal's law. Coming to the properties of fluids, at any point where the fluid is in contact with the surface, the pressure is directed perpendicularly to the surface. At any point inside the fluid, the pressure is directed in all directions with the same magnitude. The pressure at any point in a fluid increases with the depth. So, P is equals to F by A or W by A or mg by A. Let the density of the fluid is d and the volume of the fluid of which it is contained in the container is V, then density is equals to mass by volume, m is equals to Vd, where V is area of cross section into H. By substituting, therefore V is equals to AH. By substituting mg by A, V dg by A, or AHD by HdG by A, that is equals to HdG. A and A gets cancelled. What causes buoyant force? Buoyant force is the upward force on an object exerted by the surrounding fluid. When the object pushes water, the water pushes back with as much force as it can. If the water can push back as hard, the object floats. For example, boat. If not, it sinks. For example, steel. Once again, the upward force acting on an object immersed in a liquid is called buoyant force. It's also called as upthrust. Causes of buoyant force: when a mug is inside the water, the pressure from the sides are equal and no net force is available. But pressure at the bottom of the mug is more due to more depth of water and is less at the top due to less depth of the water. The difference in pressure exerts net upward force is called upthrust or buoyant force. The mug, usually made of plastic lighter than the water, is pushed up due to this upthrust. What are the factors factors affecting the buoyant force or buoyancy. The buoyant force is caused by the difference between the pressure at the top of the object, that is gravitational force, which pushes it downward, and the pressure at the bottom, buoyant force, which pushes it upward. Since the pressure at the bottom is always greater than at the top, every object submerged in a fluid feels an upward or buoyant upward thrust or buoyant force. In simple, buoyancy is nothing but the floating force. Water is heavier than the object, so the object floats. Density more likely to float. Buoyant force is measured in newtons. Experiment to study the magnitude of buoyant force. Now, when you measure the given weight with the spring balance, the weight of the body, let us assume that the weight of the body in air is 60 gram weight. Then weight of the body partially immersed in water is, let it be 50 grams. Now weight of the body fully immersed in the liquid is, let it be 40 grams. Now how do you calculate buoyant force? Buoyant force is equals to weight of fluid displaced. That is weight in air minus weight in water. Buoyant force is equals to weight of the object in air minus weight of the object in water. That is 60 gram weight minus 40 gram weight. That is equals to buoyant force is equals to 20 Newton. Another example, a person weighs 250 Newton while swimming in the Dead Sea. Outside of the water, they weigh 600 Newton. What is the buoyant force acting on them? Will they sink or float? Buoyant force is equals to weight of the object in air minus weight of the object in water. That is equals to 600 minus 250, which is equivalent to 350 Newton. The person will float because their weight in the water is less than the buoyant force. Now, what are the factors affecting buoyant force? The magnitude of buoyant force acting on an object immersed in a liquid depends upon volume of the object immersed in the liquid and density of the liquid. As the volume of solid object immersed inside the liquid increases, the upthrust or buoyant force also increases. When the solid is fully immersed, the buoyant force becomes maximum. The buoyant force depends only on the volume but not the nature of the solid object. That is, if two balls of equal size but of different metals are immersed in the liquid, both of them experience same buoyant force. Liquids having higher density exert more buoyant force than the liquids having lower density. It is easier to swim in seawater than in lake because density of seawater is more when compared to that of lake water. Even an iron block can float on mercury because of its high density, that is mercury's high density. Why object float or sink in a liquid? An iron nail sinks whereas cork floats in water. Now, conditions of equilibrium of a floating and submerged bodies. Buoyant force is greater than weight, so the object floats, which is known as positive buoyancy or positive buoyant force. When the buoyant force is equal to the weight, so the object is suspended in the fluid, it is called as neutral buoyant force or neutral buoyancy. If the buoyant force is less than the weight, then the object sinks. It is called as negative buoyancy or negative buoyant force. What is center of buoyancy? The point through which the force of buoyancy is supposed to act is known as center of buoyancy. Once again, the point through which the force of buoyancy is supposed to act is known as center of buoyancy. When an object is placed in a liquid, two forces act on it. What are the two forces acting on it? Weight of the object acting downwards, which tends to pull downward the object, and buoyant force, that is upthrust, acting upwards, which tends to push up the object. Now, whether an object will float or sink in a liquid depends on the relative magnitude of these two forces acting in opposite directions. Three cases arise. If the buoyant force exerted by the liquid is less than the weight of the object, then the object will sink in the liquid. If the buoyant force exerted by the liquid is equal to the weight of the object, then the object will float in the liquid where it is suspended. If the buoyant force exerted by the liquid is more than the weight of the object, then the object will rise in the liquid and then float. These are called laws of buoyancy. Now, coming to the principle of flotation, an object will float in a liquid if the weight of the object is equal to the weight of the liquid displaced by it. That is, weight of the object is equals to weight of the liquid displaced by it. A floating body may be partially or wholly submerged in the liquid. The liquid is displaced by that position of the body which is submerged under liquid. The density of floating objects. An object will float in a liquid if its density is less than that of the liquid. An object will also float in a liquid if its density is equal to that of the liquid. An object will sink in a liquid if its density is more than that of the liquid. In the first diagram, iron blocks sinking in water. In the second case, iron block floating in the mercury. Gave reason. A ship made up of iron floats while an iron needle sinks. In the case of ship which is hollow from within, the weight of water displaced by the ship is more than the weight of the ship, hence it floats. Whereas, in case of iron nail, which is compact, the weight of water displaced by it is much less than its own weight, hence it sinks. Once again, how does a boat float in water? When a boat is gradually lowered into the water, it displaces more and more water, due to which the upward or buoyant force acting on it increases. The boat stops sinking further down into water when the buoyant force acting on it is just enough to support the weight of the boat. When the boat is floating, the weight of water displaced by the submerged part of the boat is equal to the weight of the boat. When more people get into the boat sinks more. As long as the weight of the boat and the people together is equal to the weight of the water displaced by the boat, it floats. When no more water can be displaced by the boat, it sinks. Now, ballast tanks and density. Lowest mass, lowest density floats, whereas low mass, low density neutral, whereas high mass, high density it sinks. Shipbuilders carry compressed air tanks to refill their ballast tanks. Now coming to Metacenter. It is defined as the point about which a body starts oscillating when the body is tilted by a small angle. It is the point at which the line of action of the force of buoyancy will meet the normal axis of the body when the body is given small angular displacement. Stability of floating bodies. Stable equilibrium. If the point of metacenter is above the G, the object will be stable. Unstable equilibrium. If the point M, that is metacenter, is below G, the object is in unstable equilibrium. Neutral equilibrium. If the point M is at the point of G, then the object will be in neutral equilibrium. Once again, the density. Density of an object is defined as the ratio of its mass per unit volume. Mathematically, density is equals to mass of the substance by volume of the substance. D is equals to mYV. Density of a substance is one of the characteristic properties. SI unit of density is kilogram per cubic meter or kg per meter cube or kg meter inverse cube. CGS unit of density is gram per cubic centimeter or grams per cc. Now, why do things float? Things float if they are less dense than the fluid they are in. Things float. Things float if they are less dense than the fluid they are in. Things float if they weigh less than the buoyant force pushing up on them. Things float if they are shaped so their weight is spread out. Shape. How can you get 50 kg of solid steel to float? By changing the shape. Change the shape. Ball. Displaced water weighs less than the ball. Hull. Displaced water weight is equals to hull weight. Archimedes principle. When a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. In simple, when a body is immersed fully in water, it experiences an upward force that is equal to the weight of the water displaced by it. For example, say you have a beaker filled with water. You will observe that the water level rises and put your index finger inside it. You will observe that the water level rises slightly. You put two fingers, the water level rises a bit more. And now when you put your hand up to the rest level, you will see that the water level increases significantly. You will see that the water level increases significantly. Archimedes, he was the ancient Greek mathematician. When he got into the bathing tub, he realized that the level of water went up. In both the cases, I noticed that the water is displaced by the object that goes in. When an object is placed in or on the fluid exerts a buoyant force on it, which acts upwards. Now, Archimedes' principle. The buoyant force applied by the fluid is equal to the weight of the displaced fluid. It is equal to the weight of the displaced fluid. When an object is immersed fully or partially in a fluid, The upward force or upthrust or buoyant force applied by the fluid on the object is the same as the weight of the fluid displaced by the object. From his principle, he has given the definition of relative density. Density is the ratio of mass to its volume, that is kg meter cube. Density of an object versus density of water. So, relative density of a substance is the ratio between density of the substance to density of water. Relative density of a substance is equals to density of the substance by density of water. Relative density of a substance is equals to density of substance by density of water. Coming to the units, because both are densities and kg per meter cube by kg per meter cube both gets cancelled, and there are no units for relative density, so it is called as a mere term. Density of water is equals to 1000 kg per meter cube, whereas density of silver is 10,500 kg per meter cube. Relative density of silver is equals to density of silver by density of water, that is 1500 kg meter cube by 1000 kg meter by cube by 1000 kg per meter cube, that is equals to 10 to the power 0.5, that is equals to 10 to the power of 5. Relative density is constant only under given conditions, that is pressure and temperature dependent. Pressure by temperature, if pressure or temperature changes, relative density may change.